So 6.3b today, we've got example 1 here, v of t equals the cosine of pi over 2t, and we're supposed to find the distance traveled on the interval negative 1, 3. So how do you find distance traveled? Integral of the velocity, right? Close, that's close. It's not exactly right though. From negative 1 to 3 is right, still we're missing something. Since it's distance traveled, it's the absolute value of the velocity, right? Because we want to count this journey and this journey. We don't want them to cross each other out. Now, if we wanted displacement, that would just be the integral of the straight up velocity. But for distance traveled, we're going to integrate the absolute value of the velocity. So if this is calculator active, then you just go math 9, and then there's an absolute value button. It's a little bit tricky to find, but you can find it, and you can do this without much problem. But today we're going to practice doing this if it's not a calculator active problem. The issue is, the thing that makes it tough is we don't know how to take the antiderivative of absolute value. So we need to get rid of the absolute value signs. Now, so we need to figure out when this is positive and when that is negative. So our first job is to figure out what the function is when it's positive, when it's negative. Okay, so we're going to solve for the cosine of pi over 2t. We're going to figure out when it's positive. Now, when you solve an inequality, you're trying to figure out when it's positive. How do you start out? You have to find out when it equals 0, because that's where it might switch. So anytime you solve an inequality, first you set it equal to 0. So we got to figure out when the cosine of pi t is equal to 0. And then that's going to help us figure out when it's greater than 0. All right, so for that, we need the unit circle. So we're looking for when the cosine of a mass is 0. On the unit circle, the cosine is the x value. So we're looking for when the x value is 0. So that happens at this location and at that location. And there's a lot of names for those locations, right? One of the names for this is negative pi over 2. Another name is positive 3 pi over 2. This is pi over 2. So all the answers are pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, et cetera, and negative pi over 2, negative 3 pi over 2, et cetera, et cetera. Okay, so I always write down more than I think I need, just to be safe. And this could continue 7 pi over 2, et cetera, but I think I have enough there. And it could continue down negative 3 pi over, negative 5 pi over 2, et cetera, but I think I have enough. So if we took the cosine of these angles, we would get 0. So that means that we need this mess to be these angles. We need the pi over 2t to equal those. So then to solve for t, we're just going to divide both sides by pi over 2. So that'll give us negative 3, negative 1, 1, 3, 5, etc. So now I can consider this. The negative 3 is too small, and the 5 is too big. So those are out. But I do have 3 possible cutoff places. So then you put those on a number line. Negative 1, 1, and 3. So those are the locations where the cosine of pi t pi over 2t is 0. And now we can test in between there to see whether the cosine of pi over 2t is positive or negative in those intervals. We're just going to try 1 point in this interval and 1 point in that interval to see what's going on, to see if it's positive or negative in there. All right, so for this, I think 0 would be a good choice. So I'm going to take the cosine of pi over 2 times 0. Pi over 2 times 0 is 0. Cosine of 0 is 1. So that means that for all these numbers in between negative 1 and 1, the cosine of pi over 2t is positive. Then I'm going to test, I'll try 2 for that interval. So cosine of pi over 2 times 2. Pi over 2 times 2 is just pi. We're taking the cosine of pi, which is negative 1. So that means that for all the numbers between 1 and 3, the cosine of pi over 2t is negative. All right, so this mess that I circled here is positive in between negative 1 and 1. So what happens when you take the absolute value of it? Basically nothing, right? Because the absolute value just takes a positive number and doesn't do anything. So between negative 1 and 1, the absolute value signs are unnecessary. So I can just integrate between negative 1 and 1, the cosine of pi over 2 t dt. So in terms of the context of the problem, what's going on is the velocity is positive, so the distance traveled is going to be counted as positive on that time interval. Okay, but then between 1 and 3, the circled mess here is negative. So what's absolute value going to do to that negative number? It's going to make it positive. Another way to take a negative number and make it positive is to multiply it by negative 1. So I'm going to drop the absolute value signs and multiply by negative 1, and then that'll be the same effect in between 1 and 3. Yes?
Instead of multiplying by negative 1, you take the integral from 3 to 1.
Yes, you could. It would be the same thing.
And could you also subtract that integral?
Yeah, sure. Okay, so what's going on in the context of the problem is the velocity is negative between 1 and 3, and I don't want that journey to be counted as negative because I'm finding distance traveled, and so I'm multiplying all those velocities by negative 1 so that I count the journey as positive. Okay, so in effect, what I did from that step to this step is I got rid of the absolute value sign. The reason I needed to do that is I don't know how to take the antiderivative of an absolute value. But now I do know how to take the antiderivative of this, and I do know how to take the antiderivative of this, so I can proceed from there. Okay, so the antiderivative of cosine is sine. That's pretty much the right answer, but it's not exactly the right antiderivative. The reason that's not exactly right is if you took the derivative of this, chain rule would happen. An extra pi over 2 would pop out. So we need to multiply by 2 over pi to compensate for that. So that was backwards chain rule that I just did. Which is U substitution, right? So you could do a U substitution here. It's just one that I do in my head, and I'm trying to encourage you to do in your head. But if you go off to the side and write U equals pi over 2t, that's totally fine. Okay, so then that's going to be evaluated from negative 1 to 1. And then I like Carter's idea here of putting this negative sign out here in front. Is everybody okay with that? So then the antiderivative is the same antiderivative, because we're antiderivative of cosine. So it'll be 2 over pi times the sine of pi over 2t from 1 to 3. Or plus from 3 to 1, same thing. You get the same answer. So now all I have left to do is plug in the 1 and the negative 1 and subtract, and plug in the 3 and the 1 and the subtract, and then subtract my final answers. So I've got 2 over pi times the sine of pi over 2, because pi over 2 times 1 is pi over 2, minus 2 over pi times the sine of negative pi over 2, then minus, better be careful, 2 over pi times the sine of 3 pi over 2 minus 2 over pi times the sine of pi over 2. Okay, so then the sine of pi over 2, what's the sine of pi over 2? 1. Here, back to the unit circle. There's pi over 2, right? That's 0.01. So sine is 1. So this is just 2 over pi times 1, which is 2 over pi. Then the sine of negative pi over 2 is negative 1. So this is minus negative 2 over pi. Sine of 3 pi over 2 is negative 1. Sine of pi over 2 is positive 1. A lot of negative signs floating around. It's easy to make a mistake, so be careful. So we've got 2 over pi plus another 2 over pi plus a third 2 over pi plus a fourth 2 over pi. So altogether that's going to be 8 over pi. Everybody feeling okay about that? Just double check here. Yeah, that's what I got on my notes too, so I think it's right. Sure you don't have any questions? Trig, absolute values, inequalities, lots of stuff in there, right? Okay, so for AP students, a lot of the homework is calculator active. So a lot of it is math 9. So if you don't know how to take the antiderivative, that's okay. Just do math 9. Okay, so example 2 is BC only. So example 2 is the integral of e to the x cosine of 2x dx. Okay, so this is a u dv problem. So we're going to have u equal, well, there's a couple of choices, so let's try this. Okay, so then you take the derivative of this, and you get the derivative of cosine is negative sine. There's going to be a chain rule. That's where the 2 came from. And then the antiderivative of e to the x is just e to the x. Yes.
I think you told us that you didn't problem, but like it was on the homework, we just try to see.
Yeah, I mean, generally, so the first clue is the multiplication in the original problem. Now, that's not to say that there's multiplication in u substitution also. But if you had u equal this, then what pops out is a 2. So for it to be a strong candidate for u substitution, what's sitting here needs to be the derivative of the inside. Like if that was a tangent, and this was a secant squared, then that matches up pretty well for u substitution, because the derivative of the inside is what's being multiplied. But this one, since it's multiplication, and since the derivative of the inside is not matching up with that, I don't like to give hard and fast rules, but it's more likely that it's UDV. Great question, because you're right. They're mixed up problems on the homework and on the AP test. So, okay, so then you take u times v. So that's e to the x cosine of 2x. Minus the integral of v du. So then, if you're okay, I'm just going to turn this into a plus. Because the minus and negative is a plus. Okay, now remember, the general rule of thumb is, if you get to this stage and you don't know how to do this antiderivative, then you're on the wrong track, right? This looks pretty much the same as the original, except the cosine's turned into a sine and we got an extra 2. But I think we should persevere. This is one where the general rule doesn't work. So we're going to do it again on this. So now we're going to have u equal sine 2x and we're going to have dv equal 2e to the x dx. So then here you do the antiderivative, which is 2e to the x. Here you do the derivative. Sine is cosine. So then I'm going to just pull this down. e to the x cosine of 2x plus, now the new u times the new v, so 2e to the x sine of 2x minus the integral of v du. So that's 4 e to the x cosine of 2x dx. Forgot my dx on here. Probably because I couldn't write it on the metal here. So how do you feel about this? Not so good, right? Because this is supposed to be an integral that we know how to do. And it's even worse than the original, right? Okay, but according to the theorem, this whole mess is equal to my original integral, right? So I was trying to figure out this integral, and I know that it equals this. So how about if I add this to the other side? So I've got one of these integrals plus 4 of these integrals. So altogether that would make 5 of them, right? So that means that 5 times the integral of e to the x cosine of 2x dx equals e to the x cosine of 2x plus 2e to the x sine of 2x. So then what do I do to figure out this integral that I was trying to find? This is the original problem, right? I need to know what this is. So how am I going to get that? Divide the 5, right? So the integral of e to the x cosine of 2x dx equals 1/5 e to the x cosine of 2x plus 2/5 e to the x sine of 2x. Okay, so this is a bothersome problem because I never actually took an antiderivative. Yeah, good. So you're chuckling, that means you see what happened. It seems like mathematical sleight of hand that just happened. I never took an antiderivative, yet I figured out what the antiderivative was. It was just a really specialized case with the e to the x and the trig, because the trig cycles back to itself, right? If you take 2 derivatives. And the e to the x just stays no matter how many antiderivatives you take. So that's why it cycled back to itself. And that's why I was allowed to add this to itself. So it's a real specialized problem. It's not going to happen like that very often at all. But there's one like it on the homework, so I needed to show you. Okay, so let's say that was part A. Yes, yes.
Because it was a trig function, you know you were able to, like at the first step when it didn't really work out, you know that if you kept going, they were
I knew if I went one more time, this sine would turn into a cosine.
Right.
And then I'd be back to cosines, which was my original. And so then these cosines would match up with this cosine that was over here, and I could combine them.
Okay.
Yes. So, yes, exactly.
Basically, you just got that by being smart about calculus.
Yes. But it was a very, very specialized trick that will not work very often at all. But there's one like it on the homework, and it's cute enough that I like to show it. I can't tell you. Oh, I don't know what's on the AP test. So that's why I don't tell you what's on my test. Because I gotta get you ready to hit any pitch they throw. Curveball, fastball. Baseball's about to start, so I can start talking baseball. The Reds had their first spring training game yesterday. Okay, so let's say that was part A, and then let's say this was part B. So what's the difference between part A and part B? It has numbers, right? So in part A, we were just finding the antiderivative. But in part B, we're actually computing an area. It's a definite integral rather than an indefinite integral, right? So, but how do you find area? The first step is to take the antiderivative, right? So here's my advice. When you get a problem that's a standalone like this, I mean, we already have the antiderivative, so we're going to use it, right? But let's say you have a standalone problem like this. It might be tempting to maybe put some numbers here and then here, but that gets confusing. So my advice is, when you have a problem like this, get rid of the numbers and figure out the antiderivative first, just like we did on part A. And then, when you have your antiderivative, then go back to this and write it down and put the line 0 pi over 2 at the very end. So don't bother with numbers and numbers and numbers. Just leave it as a straight up antiderivative sign instead of an integral. Okay, so but knowing that, we would then take the antiderivative, which would come out to 1/5 e to the x cosine of 2x plus 2/5 e to the x sine of 2x. So there's an antiderivative, right? And then we're going to do that line 0 to pi over 2. Seem concerned, Carter. Remember, the fundamental theorem says that I can use any antiderivative that I want. So I'm using the one where the c is 0. Okay, so then you plug in the pi over 2 and the 0 and subtract. That's going to be a big mess. That's okay, we can deal with it. So we got 1/5 e to the pi over 2 cosine of pi, which is -1. So this will be -1/5 e to the pi over 2. Plus sine of pi is 0. So that's nice. And the cosine of 0 is 1. Oop, that should be a 2. Oh, yes, that should be a 1/5, sorry. The 1/5 e to the 0 cosine of 0. But the cosine of, well, let's write it down. Cosine of 0 plus 2/5 e to the 0 sine of 0. So we've got negative 1/5 e to the pi over 2 minus 1/5 minus 0. The final answer is negative 1/5 e to the pi over 2 minus 1/5. Everybody doing okay? Are you sure?